Normally you wouldn't believe it, I guess, but I normally try and plan out my videos a little bit. I kind of look through the lesson, and I started looking through this lesson and realized this is going to be a lot of jumping around. So then I just started the video. So we'll just see how this goes. But I'm going to be bouncing back and forth from different things. So please bear with me. So angles formed by transversals. So in Lesson 131, you use the properties of supplementary angles and straight angles to show that vertical angles are congruent. Today we'll use a tile pattern to investigate other angle pair relationships. And if you remember from yesterday's video, or the last video, I'm making them back to back, whatever, we have these other congruent relationships to discuss, as well as the same side interior. So that's really what we're going to be doing, is diving into some of these, if not all of these. Honestly, I don't know if we get through all of them by the end. So it says, Marcos was walking home after school when he noticed a pattern of parallelogram tiles on the wall of a building. Marcos saw lots of angle pair relationships in the tile pattern, so he decided to copy it into his notebook. In the beginning of Marcos's diagram is shown at the right and provided in lesson 132. So this is what it looks like in the beginning. It says this type of pattern is called a tiling. In this tiling, a parallelogram is copied and translated to fill an entire page without gaps or overlaps. View this interactive e-tool Marcos tile pattern. So it's kind of cool. Marcos's tile pattern, you just sort of move these things along and you can see that what happens is it just sort of makes these tilings. So that's kind of what they're going with there. So it says, recall that two polygons are congruent if there is a sequence of rigid transformations that carries one polygon onto the other. Describe three different sequences of rigid transformations that can be used to carry one parallelogram onto the other in Marcos's diagram. So if you think about this goes back to integrated one, where we first of all have a translation, right, where you just sort of slide it over and it could be on top of each other. Then we have a reflection, right? This is a line of reflection where if you kind of, it's like a mirror image of it. And then a rotation where if we kind of flip this thing around 180 degrees, it would look the same as well. So same three rigid transformations we had from integrated one. Again, translations of the slides, reflections, and rotations. It says, consider the angles inside a single parallelogram from the pattern. Which angles are congruent? How can you justify your claim? Well, hopefully we know that if we look here, right, that this angle and this angle are going to be the same, right? Because these are vertical angles, so they have to be the same. And these angles will be the same because they're also vertical angles, so they have to be the same. So really what that's saying is this. I'll use different colors here. But these angles are vertical angles, right? Actually, I used a poor example. I should have chosen something more in the middle. So I know that these angles are congruent. They're vertical. And I also know that these angles are also congruent. Well, think about this. If I take this one and slide it over, that's the same. All the bottom lefts are the same. All the bottom lefts are orange because I'm just sliding it over. Well, aren't all the top rights also orange? Because we know they're vertical. So I'm going to get these relationships. And I hope that makes sense. But the green, right? All the top lefts, if I slide this over, the top left is green. And I slide this over, the top left is green. And I slide it down, it's green. So all the top lefts are green. But again, because they're vertical angles, we also know that all the bottom rights are also green. So we'll go here and we'll mark this. So really we know that these are going to be our angle relationships, and I hope that we see why that would be the case. Kind of interesting how that breaks out and why that is. Alrighty. So since each parallelogram is a translation of another, what can be stated about the angles in the rest of Marcos's tiling? I think we jumped ahead. Using an e-tool or tracing paper to determine which angles must be congruent. Again, we already did that. Color all angles that must be equal measures, the same color. We already did that. We used the orange and the green. So what about relationships between lines? Can you identify any lines in the diagram that must be parallel? Mark these lines on your diagram with the same number of arrows which are shown are parallel. Okay, so the bottom line would be this. If I look at this, I know that, hey, I'll go back to black here. I know that this line and this line and this line and this line and this line are all parallel. And I know that these lines are all parallel as well, right? They're never going to touch. they go in the same direction. So I only need one arrow or one caret in this direction because they're all parallel to each other, and I only need one in this direction because they're all parallel to each other. All right. So it says Julia wants to learn more about the angles in Marcus's diagram and has decided to focus on just a part of his tiling. And a large view of that section is shown in the image below right. So you can see he's got the angles with the line here, which is known as a transversal. So it says Julia wants to learn more about the angles in Marcus's diagram and has decided to focus on just a part of his tiling. And a large view of that section is shown in the image below right, with some points and angles labeled. So it says a line that crosses two or more other lines is called a transversal. In Julia's diagram, which line is the transversal? Well, it looks like this is the transversal because it's crossing two lines. Which lines are parallel? Well, LM and NP are parallel here, right? So let's go over here and let's sort of mark this thing up so it looks kind of like what we're talking about here. So I think what we're doing is we're keeping these lines. So we're going to go ahead and we're going to fill in some of this stuff, right? Just to get rid of some of the stuff that we don't want. So here we go. We are left with these parallel lines right here and this transversal, right? That's roughly what it looks like over here in the book, I think. Those parallel lines with that transversal, those parallel lines with that transversal. Somehow I managed to have erased. This should be an orange dot. Okay, so let's go ahead and continue along. A line that crosses two or more other lines is called a transversal, so probably a good idea to go back to the sheet and mark in what a transversal is, maybe even show a quick little drawing of it. And it says trace angle X on tracing paper and shade its interior. Translate X by sliding the tracing paper along the transversal until it lines up with the angle that matches it exactly. Which angle in the diagram translates to X? Well, you can see X and B will slide up to each other, right? X slides up to B. In this diagram, angle X and B are corresponding angles because they are in the same position and two different intersections of a transversal. So what is the relationship between X and B? Well, we know that X and B, right? Here's X and here's B. X and B are congruent, right? They're both orange because we slid it up. So we know that we can go over to our sheet and we can write corresponding angles, right, are congruent. And that shouldn't be a surprise because it's already under the congruent umbrella here. But one thing I do want you to recognize about this is this, that when we say this one right here, let's go ahead and clean this up a little bit. I think we got a lot going on here, so that was unfortunate. Boy. Okay, let me pause and set this up. I coded this and went with the same letters and stuff. So you can see X and B are the same color, so we know they're congruent. But I also want you to kind of notice something here. Let's say I sort of block this part out. And I only look at this. Do you see that B's in the top right corner? Well, what if I do the opposite here? Do you see that X is in the top right corner as well? That's what it means to correspond, that they're in the same spot. B's in the top right and X is in the top right. And if these lines are parallel, if they're in the same spot, they'll be congruent. Look, D and Z are in the bottom right and they're congruent. They're the same color. A and W are in the top left spot. C and Y are in the bottom left spot, and they're congruent as well. So that's what it means to be corresponding, that you're in the same spot, top right, top left, or whatever it might be, and that you're congruent. But again, the lines have to be parallel. If the lines aren't parallel, that doesn't matter, which we'll learn as we go through this lesson. So hopefully we're okay with where we're at right now and what a corresponding angle is. Corresponding angles formed by parallel lines. The corresponding angles in Julia's diagram in problem 182 are congruent because they're formed by translating a parallelogram. Name all the other pairs of corresponding angles in Julia's diagram from 182. And again, we said A and W are corresponding. They're both in the top left. C and Y are corresponding. They're in the bottom left. B and X are in the top right. They're corresponding. And D and Z are corresponding because they're in the bottom right. Suppose B equals 60 degrees. Use what you know about the angle relationships to determine the measures of all the other angles. So B equals 60 degrees. Well, if B equals 60, what does that tell me about the rest? So if B equals 60 degrees, I know that C equals 60 degrees because they're vertical. I know that X equals 60 degrees because they're corresponding. I know that Y equals 60 degrees either because C and Y are corresponding or because Y and X are vertical. I know that A must equal 120 because they're supplementary angles. I know that D must equal 120 either because A and D are vertical or because B and D are supplementary or because C and D are supplementary. So you can see all these different relationships and why you need to know them. A and W are corresponding angles and D and Z are corresponding angles, or X and Z are supplementary and should add up to 180, or Y and Z are supplementary and should add up to 120, or W and Z are vertical, should be equal or congruent to each other. There's a lot of different ways that we can say this, so hopefully we're okay with that. So are they always congruent? So far you've investigated transversal lines that cross pairs of parallel lines. However, transversal lines can cross any pair of lines, not just parallel lines. So Frank wonders whether corresponding angles are always congruent. For parts A through D below, use tracing paper to determine whether corresponding angles are congruent. Then if you have enough information, determine angle measures X and Y and state the angle pair relationship. So what I'm going to do is pause this and set this up. Basically say, hey, look, X and 135 are corresponding angles. So I know that this equals 135 degrees. And I know that X and Y are vertical. So this has to equal 135 degrees as well. So there you go. By the way, these are 135, this 135, and this Y would be alternate exterior angles, which we'll talk about more as we go on here. But yeah, those are going to be the same. If you use tracing paper, those match up. If you use tracing paper, you're going to know that X and 135 don't match up. So even though they are corresponding angles, they're not congruent. So I'll never be able to solve this, but this one I can easily solve because they are supplementary. So this one has to equal 45 degrees, right? 135 plus 45. Here, hey, look, this angle and this angle will match up perfectly. So they're vertical, they're 135 degrees, and these are supplementary. So that's 45 degrees. So again, corresponding top left are equal because the lines are parallel. Again, the lines aren't parallel here, so it doesn't work. The lines aren't parallel, so I can say that this is 45 degrees because of supplementary angles, but I can make no claim about this Y. So are corresponding angles always congruent? No. If not, when are they congruent? When lines are parallel. This is the parallel sign. So if lines are parallel, that's something you need to check. Lines have to be parallel. All right, so proofs of corresponding angles theorem. Conjectures and theorems are often written in the form if-then. A statement in if-then form is called a conditional statement. So make a conjecture about corresponding angles by completing this sentence. If-then. So, and it's saying then corresponding angles are congruent. So my if-then will be if lines are parallel, then corresponding angles are congruent. That will be my conjecture. That seems to make sense for what I'm seeing here, but the lines have to be parallel for the corresponding angles to be congruent. So prove your conjecture from part A is always true. I don't want to get into that too much. Let me pause this and set this up, I guess. Yeah, I was going to say, I kind of looked at the teacher's edition here, and normally when we do proofs, we don't just use translations, but they use translations. Hey, we can slide something over and they're the same, so it must be true. It's kind of a weak proof, so I'm going to just ignore that anyway. Plus, I don't have graphing paper. I just didn't know if they wanted to just do a real proof like we did previously with vertical angles, but they don't. All right, so it says for each diagram below, the value of x is possible. Determine x if possible. If not possible, explain how you know. State the angle pair theorems you use. Be prepared to justify your reasonings. to other members of your team. So I love problems like this. I think they're fun puzzles here. So if I look, hey, look, these lines are parallel. So I can say that this equals 115 degrees because those are corresponding angles, right? That's in the top left, that's in the top left. And hey, look, this is also in the top left. So I can also say that's 115 degrees because those are also corresponding angles. And now I can say that these are supplementary angles, so they have to equal 180. So I will say, what, 65 degrees? So x must equal 65 degrees. 115 plus 65 equals 180. So again, I used corresponding angles to get to here, corresponding angles to get to here, and then supplementary angles to finish it. And that was only true because the lines are parallel. All right, how do I go from here to here? Well, this must be 53 degrees because these are corresponding angles. And now I'm kind of stuck, right? These are no longer parallel lines, so I don't really see how I could possibly get down here. I have no idea what angle this line is at, so I don't think I can solve B. If I go to C, I don't really care what this angle is. I'll worry about that in a minute, but I know that these lines are parallel, so these corresponding angles are the same. So top left are the same, and then these are parallel lines as well, so top left and top left are the same. So I know that this equals 4x minus 25. And guess what? 4x minus 25 must equal 3x plus 10 because they're vertical angles. So I can write my equation. 4x minus 25 is equal to 3x plus 10 because of vertical angles. I'll add 25. I'll subtract 3x. So I will go x equals 35 degrees. Again, if I sub in 35 here, I get 140 minus 25 is 115 degrees, so this equals 115 degrees. I want to get 115 when I plug 35 into here, so I get 105 plus 10 is 115, so you can see that did work out. Again, the crucial thing, parallel lines, so I can solve it. No parallel lines, couldn't solve it. Parallel lines, I could solve it. Make sure you realize that corresponding angles are only true, or only congruent, I should say, if the lines are parallel. And again, don't forget this sheet.